Today I will be covering video number 13, which is the implementation of my mini lathe DC motor spindle controller. Now, the controller has the ability to control uh, the spindle RPM as well as its direction. Okay, so this is my implementation. Now, previously in video number 12, I've covered on the topic of the HQSX PWM, how you configure it and how you utilize uh, the controller for this application. Now, as I mentioned before, my mini lathe utilizes a brushed DC permanent magnet motor, which is rated at 180 volts DC. So as previously, I've configured my controller to also provide a maximum of 180 volts DC. Of course, due to tolerance, it does fluctuate here and there a little bit. Okay. So anyway, okay, how this overall package works is it consists of the HQSX PWM, which receives analog 0 to 10 volts from the breakout board. Um, please refer to the description below. I've provided a Google Drive link for you to download the entire wiring diagram that I have implemented for my CNC mini lathe, as well as how I have implemented this entire DC motor spindle controller. Okay, so if you I will explain more on the circuit along during this video. Okay, so at the moment I'll just show you how it works first, and then I'll explain later on the circuit. Okay, so basically if you see here, there are these cable glands. Okay, this cable gland with the white color cable is the analog 0 to 10 volts that comes from the breakout board. I'm using the a parallel port ST-V2 breakout board, and then at the same time I have my DC power supply, which comes from my DC from my breakout board and CNC controller. Basically, the 12 volt is just an auxiliary power supply, which I make it available at this connector, and I just supply this over here to power the relays. The relays here are 12 volt DC relays, as well as this relay. I'll explain a little later about the relay. Okay, and the same, then I also have my M3 of clockwise, counterclockwise, depends on your lathe, spindle control signal M3, and this is another spindle control signal called the M4. They are all connected to this controller board, which is from output number 1 and output number 2 respectively. Okay, and then the last last cable here, which is in black, is my AC power. For my case is European value, which is 240 volts RMS, connected to supply the HQSX PWM through pins line, neutral, and earth respectively. There is a small green cable that comes out from the controller with a bung here. This will be connected to the chassis ground of the mini lathe, and is also grounding the DC motor that is used for the spindle. Okay, so this is just a common ground or earth ground to the controller, and also common throughout the entire system. Okay, so if you see here, there are 3 relays: relay number 1, relay number 2, and relay number 3. Relay number 1 controls the direction of the spindle. Okay, if it is de-energized, the spindle will rotate counterclockwise. Okay, the reason is counterclockwise for my case because I have a forward tool post. Okay, if the relay is energized, it will cause the spindle to rotate clockwise direction or reverse rotation. Okay, and then you have uh, two more relays number 2 and relay number 3 respectively. Relay number 3, which is this one, controls the enabling and disabling of the HQ-SX PWM. There is an enable pin and a ground. All it does is just enables and disable according to the M3 and M4 command. The idea is to disable HQSX PWM, go into a standby mode. Standby mode is indicated by the rated voltage followed by the analog DC input, either 0 to 10 volt or 0 to 5 volt. Will indicate here almost 0, or sometimes it's exactly at 0. If you see here the voltage followed by some numbers here, this means it is disable mode, means it is under standby condition. Okay, so there's no output being driven by this unit. It will not respond to any analog voltage. There will not be any output to the spindle motor. Okay, relay number 2 is used to do two things. One, it is used to apply drive mode. Okay, at the same time it is used to apply dynamic brake. What it does is this relay will, under drive mode, will disconnect a parallel brake resistor across the DC motor, thus allowing it to rotate freely under function of Mach 3. When it is disabled or de-energized, it will cause a brake resistor to be in parallel with the motor, thus causing it to apply some form of braking. Let me go through the configuration, how I set it up. So go under pots and pins, go under spindle setup. Okay, this is how I've configured my CNC lathe. So M3 is configured to output number 1, M4 is output number 2. So relay number 1 and relay number 2 respectively. M7 is for mist, is relay number 4 or output number 4, and M8 is relay number 3 for flood. Okay, this we can use for switching on, switching off pumps. Okay, the output is available here for 1, 2, 3 and 4 respectively. You can see the labels are there. Okay, now back to the configuration now. Okay, if you look carefully, you need to enable use spindle motor output. This allows M3, M4 to work as to switch on and switch off the output number 1 and output number 2 relays respectively. You need to switch on to PWM mode. Okay, PWM mode is needed for you to drive some form of analog voltage on your breakout board to give you 0 to 10 volts DC or some form of pulse width modulated signal. Okay, the breakout board is available. The analog output of the breakout board is available in two forms. One is a pure analog voltage 0 to 10 volts, linearly proportional to the speed of the spindle, and also PWM signal, 0 duty cycle all the way to 100% duty cycle. Okay, next thing, you need to select use spindle feedback in sync mode, closed loop spindle control, and spindle speed averaging. Spindle speed averaging is for your tachometer, your S-true value. Okay, and then this is your proportional, integral and derivative or PID values for you to synchronize your spindle RPM with your desired RPM. This means, I will demonstrate with Mach 3, you have the ability to say command 200 RPMs spindle speed, desired speed, and then Mach 3 will maintain the spindle at 200 RPMs. I'll show you that in a little later in the video. Okay, so At the same time, I set my clockwise delay spin up. This is your ramping up in a clockwise direction, 4 seconds. Ramping up in the counterclockwise direction, 4 seconds. And ramping down is always less. You can put it same, but I prefer for it to be less, faster to ramp down. So 2 seconds, 2 seconds respectively. Okay, you can set anything between 2 to 4 seconds, it'll be okay. 1 second is okay, but I prefer give it a little bit of time. Okay, now you need to disable the relay off before delay. The reason is if you enable this, dynamic brake will apply quite hard and it causes arcing at the relays. So what I found that if you disable this, it will allow the motor to decelerate and apply dynamic brake. Okay, so these values PID you can set according to some experimental value. I've chosen my values which works at the moment. Later I might need to tune it. Okay, there's also other parameters in the HQ SX PWM controller over here you can set as well. So it's a bit of a trial and error, but this works. I will demonstrate in a while. Okay, so if you observe now, I will, after you've done setup, you apply OK. Now I will increase the spindle RPM, okay, to say 700. So S 700, enter. Can you hear now? The spindle is spinning faster in a counterclockwise direction at 700 RPMs, true RPM. Desired is 700, actual is 700. Okay, now if I were to stop it by keying in the command M5, okay, spindle has stopped. Okay, you can hear the beep. The beep is from the HQ SX PWM. Okay, so now spindle speed is 0. Okay, now let's start back the spindle. Remember, my speed is still set to 700 RPM. So if I switch on M3, sorry, it will spin in counterclockwise direction with a spindle speed of 700 RPM. So M3, enter. Spindle starts again, climbing up to 700. We are there. Okay, observe now. S500. Reduce it. Drop down to 500 RPMs. Okay, 500 RPMs. Now, let me change direction without going through M5. So M4 now. From M3 to M4. Motor stops. Couple of seconds delay and switch reverse rotation. Now it goes in the clockwise direction at 500 RPMs. Okay. Again, I will move from M4 clockwise to M3 counterclockwise. So when I type in M3, enter, spindle will stop, decelerate, stop, delay a couple of seconds, and then only switch on in the counterclockwise direction. 1, 2, 3, 4. There. Counterclockwise direction. Okay, M3. Okay, watch what happens if I were to S800. I'll go faster. I'm spinning at 800 RPMs. S800. Okay, now I'm in M3. I will switch to M4 abruptly. M4. Enter. Observe. Decelerate, stop, dynamic brake, then spin opposite direction. Okay, now S500. Okay. S600. S700. S1000. 1000 RPMs. Remember, I have a bearing and gear problem. Okay, it's spinning at 1000 RPMs. You can see the belt the pulley. This is the index sensor. This is a sensor for the external tachometer, and you can see the voltage that is being driven by the breakout board. Okay, now I will switch direction. I'll stop first, M5, slow down, stop, delay, that's it. Then M4, reverse, opposite direction, 1000 RPMs, yes, 500, slow down, and finally M5, stop. Now I've loaded a sample cam program, and this cam program is to cut this profile. We have a cylindrical stop. It will cut by selecting several tools, and finally you'll get this result. So this program will have variable spindle speed, tool changing, as well as on and off spindle. So let me just rotate the tool turret. Okay, so here's the tool turret you've seen before. So I'll demonstrate the full capability of the CNC machine. So my CNC mini lathe. Okay, observe when I'll start cycle start. Hang on. Okay, so we have cycle start. Okay, tool 2. It will turn to tool 2. Switch on spindle. Spin it at 600 RPMs. Okay, now it's moving the X and Z axis respectively, spinning the spindle. Tool is still tool number 2. Tool number 2. Okay, now M5, stop, home, home, change tool number 3, start spindle, M3, S600, roughing. Rough cut, still rough cut. We are still tool 3, tool number 3. Coming to final rough cut. This is a tool path. Okay, coming to finishing cut, and then it will switch off the spindle, return to home, change to the next tool. Okay, we are coming almost to the end. Switch off spindle, return to home, home X, home Z, and then change to tool number 8 once he has reached home there. Tool number 8. Again, start the cycle, run the spindle at 600 RPMs. You notice there is a delay when the spindle ramp up, spin up, and then the tool moves in to take the cut. It's set in such a way that there is a delay to give it time to ramp up, spindle speed to ramp up, maintain the RPM to 600 RPMs, and then start cutting. Okay, so we're still tool number 8. Okay, we are coming to final rough cut. Almost there. After it should be the finishing cut. Don't forget the spindle RPM fluctuates partly due to the damaged gears in my mini lathe as well. Okay, switch off. Okay, let me switch my spindle to on M3. I'm spinning at 600 RPMs. Don't forget, I've set it previously to 600 RPMs. Okay, observe. I'll take this cloth. I'm going to, before that, let me reduce the spindle speed because a bit as 400. Okay, I'm spinning the spindle at 400 RPMs. Okay, please do not do this at home. I'm going to use this cloth to resist the spindle to show you that when the spindle RPM drops, Mark III will try to compensate for that drop in speed to keep it constantly running. Okay, I'm going to carefully hold this. Okay, my cloth is coming apart, so just give me a second. Okay, see, I'm resisting the spindle speed, and Mark III is maintaining it at 400 RPM. If I let go, it will slowly accelerate and smoothen out. Please do not try this at home. Be careful with your fingers. I just show you at very low RPMs that it can regulate the speed.